Start. Okay, Assalamualaikum and very good morning. Okay, so my name is Muhammad Arif Akmal. So I will present number 5. That is find application of each of the Conic section. So first of all, we will jump into hyperbola first. Okay. Lorentz is referred to as a hyperbolic system. In order for the Lorentz system to work effectively, the Lorentz receiver must be connecting with at least 3 transmitting stations. This set of 3 stations is called chain. One of these stations is designed as the master station, and the other 2 are secondary stations. Okay. Hyperbola has a very important distance property that helps locate the shapes. The hyperbola is set of all points where the difference in distance to each of the 4 sides of the hyperbola is constant. This special property is the foundation for Lorentz. Imagine that the world is flat and that the coverage error if a chain can be shown in Cartesian plane. The master station and 2 secondary stations are plotted on the grid. To find the location of the Lorentz receiver, presumably on a sheet, we need to find the difference in distance from each master or secondary pair to the sheets. This distance can be converted to longitude and latitude coordinates, and the master secondary pair become the foci of a hyperbola. Okay, this same process is repeated for the other secondary station and the master station, where the 2 corresponding hyperbolas meet in the location of the sheet. Because we are able to find which station this sheet is closest to, there is only one possible location for the sheet. Okay, as shown in this figure. Okay, in the figure above, M and S1 are the focal point of one hyperbola. M and S2 are the focal point for the second hyperbola, where this hyperbola meet in the location of the sheet. Okay, next about circle. Okay, similar to the Lorentz system, GPS works successfully with the transmission of signal traveling at the speed of light. In the case of GPS, we are working with satellites instead of station. GPS use 24 satellites that orbit the entire Earth, and hence it can provide important navigational information anywhere in the world. Also similar to Lorentz, 3 satellites are needed to find the altitude, longitude, and latitude of GPS receiver on the Earth. The satellites send signals that are picked up by the GPS receiver, just like the Lorentz system. The receiver is then able to find the distance from each of the 3 satellites to the receiver. Because we know how fast the signals are traveling, that is speed of light. The simple formula provides us with this information, which is distance equal to speed times time. Instead of using the hyperbola, each of the 3 satellites becomes the center for a sphere with a radius equal to this distance were calculated using the formula. The 3 spheres will interact at 2 points, one of which is usually unrealistic, perhaps below sea level. If there are 2 possible points, a 4 satellite distance calculation may be needed. The appropriate point of intersection is the location of the receiver. The process of using 3 or more spheres to locate a point is called trilateration. Okay, the picture above shows 3 circles of varying distance centered around satellite S1, S2 and S3. The point where the three circle or sphere, as in the case with GPS, meet in the location of GPS receiver. Okay, GPS and Lorentz system are built on the foundation of fairly common mathematical concepts, conic section and distance formula. Although the actual mathematics involved requires rather complete calculation, it is helpful to understand even broadly how this system works. Okay, the next one is about ellipse. Okay, ellipse is nevertheless the curve most often seen in everyday life. The reason is that every circle viewed obliquely appears elliptical. Any cylinder sliced on an angle will reveal an ellipse in cross-section, as seen in the Tycho Brahe Planetarium in Copenhagen. Okay, you can see the picture. Okay, for example, we are using a glass with water. The glass of water and the surface of the liquid acquires an elliptical outline. So it's often cut oblique to obtain elliptical slices which are larger. Okay, the early Greek astronomers know that the planets move in the circular orbits about an unmoving Earth. Since the circle is the simplest mathematical curve in the 17th century, Johannes Kepler eventually discovered that each planet travels around the Sun in an elliptical orbit with the Sun at one of its foci. Okay, the orbit of the Moon and of artificial satellite of the Earth are also elliptical as the path of comets in permanent orbit around the Sun. Okay, you can see the orbit that have a shape of ellipse. Okay, Halley's Conic takes about 76 years to travel about around Sun. Edmund Halley saw the comet in 1682 and correctly predicted its return in 1759. Although he did not live long enough to see his prediction come true, the comet is named in his honor. On far smaller scale, the electron of an atom moves in approximately elliptical orbit with the nucleus at one focus. Okay, we jump to the next one, which is parabola. One of the applications of parabola involve the concept of 3D parabolic reflector, in which parabola is revolved about its axis, which is the line segment joining the vertex and focus. The shape of car headlight, mirrors in reflecting telescope and television, also radio antenna, such as the one below. You can see the picture. Okay, all these have a shape of parabola. Okay, all incoming rays parallel to the axis of the parabola are reflected through the focus. Okay, another one is flashlight and headlight. Okay, in terms of car headlight, this property is used to reflect the light's ray emanating from the focus of the parabola, where the actual light bulb is located in parallel rays. Okay, the last one is part of projectile. Galileo Galilei found that all objects thrown from a parabolic path, no matter what. He deduced this by the simple observation of watching objects being thrown. Galileo is responsible for the modern concept of the velocity and acceleration to explain projectile motion that us to study today. A projectile which is carried by uniform horizontal motion compounded with a natural accelerate vertical motion describe a path which is semi-parabola. So that's all from us. Hope you will enjoy the video and thank you.